In the next coming lectures, I'll be talking about Kubernetes basics. So all the previous lectures were just an introduction. I just showed you how to set up your cluster and how to run a simple application. Now we're going to go a little bit deeper into detail how to run different kind of workloads on Kubernetes. I am first going to start with an architecture diagram. I'm going to give you a 10,000-foot overview of how the nodes in Kubernetes work. This is the architecture diagram and it has a lot of information. So let's start here with something that you already know. In green, you can see the pods. So we have pod 1, 2, and 3 on node 1 and pod 4, 5, and n on node 2. These are pods like we've started in the introduction. Within those pods, you have the containers. So we had just one container, just like pod 2 and 5 only have one container. So the containers here are denoted in red. You can have multiple containers. If you take a look at pod 3, then you see that pod has 2 containers and pod 1 has 3 containers. Those containers can communicate easily to each other. They can just use the port number, so a localhost and a port number, to communicate with each other. If you have 2 small services, let's say one is the backend and one is an authentication service, they can easily communicate with each other. Pods within a cluster can also communicate with each other, but that needs to go over the network. I will show you later on how service discovery works so that pods can easily communicate with each other. Those containers in those pods are running using Docker. So on our nodes, we all have Docker installed. You can also use an alternative container engine, but in our examples, I'm always using Docker. On those nodes, you also have a kubelet and a kube proxy service running. So the kubelet is responsible to launch the pods. So it's going to connect to the master node to get this information. The master node is not shown on this diagram. It's only the nodes that are shown here. The kube proxy is going to feed its information about what pods are on this node to IP tables. And IP tables is the firewall in Linux and can route traffic. So whenever a new pod is launched, then kubeproxy is going to change the IP table rules to make sure that this pod is routable within the cluster. That brings us to the service. And the easiest way to remember how a service works is just to imagine yourself a load balancer. So this can be, for instance, the ELB, the Elastic Load Balancer on AWS. This Elastic Load Balancer on AWS is going to be publicly available. So clients from the internet can connect to this load balancer, and this load balancer is then going to forward the traffic to our Kubernetes cluster. It's going to have all the nodes listed, and the traffic is all going to arrive at IP tables. IP tables has then the rules to forward traffic to another node. For instance, if the pod is running on another node, then it needs to go to this destination node. If the pod is on that node, then it will just forward the traffic to the pod and to the specific container in this pod. You have seen that in the AWS example, we have exposed a node port, like a static port. The communication between the service and the nodes is going over this one port. In AWS's case, the ELB just has one port configured. All the nodes listen to that port and IP tables will just route the traffic that comes from that port to the correct pod. To translate this to our YAML file, let's have a look how this looks. So we have here a container and we have the pod definition. So when we started our Kubernetes demo, this specification, this spec here, refers to a container, and this container refers to this red block within this pod. The whole green pod is actually the full definition that you see here on the right. The container is just everything you see under spec. If you would have 2 containers, you would just have a spec with 2 containers.